All right, everyone. Thanks for joining this code webinar for Pennsylvania. We will be beginning the meeting in about 1 minute. We're just going to give it a couple more to let everybody join in. All right, Travis and Pat, why don't you get started? And we are recording this event, everyone, just so you know. And after the event, you will get a copy of this recording in an email that should be coming out tomorrow. So I'll turn it over to Travis and Patrick.
Sounds good. Thanks, Michelle. And again, thank you for all your time spending with today. As Michelle mentioned, today we're going to be covering the latest energy code changes happening in the state of Pennsylvania. With me is Pat Nielsen. And what we're going to do today is we're going to utilize the Q&A function to answer any questions as we go through this presentation. Michelle will be monitoring that as they come up and irrelevant to the conversation. She may bring those up. Otherwise, we'll take time at the end. Planning on this presentation taking about 40 minutes or so, and we'll leave another, again, additional 20 or so to answer those questions that were not answered during the presentation. And again, thank you again for your time, and feel free to enjoy this session. So again, with me is Pat Nielsen. Pat's our Global Technical Product Manager. Pat's going to cover for us much of the details related to the codes as it relates to ventilation. And again, I'll introduce myself, Travis Rash. I'm the Group Product Manager, mainly focused on what we call our fresh air systems, or in this case, the energy recovery ventilators, or ERVs. So with that, I'll go ahead and turn it over to Pat here shortly. Again, just a reminder for those that aren't familiar with Broan, or maybe just have some exposure to Broan. Broan's been in the ventilation industry for over 90 years now. I think we're going on 92. We have a full suite of different ventilation products. Probably typically best known for our exhaust ventilation or bath fans. We have a full suite of products within those, ranging from a small 50 CFM bath fan all the way up to a 300 plus CFM light commercial exhaust fan. We also have a wide range of kitchen ventilation products under the Broan brand, among many others. Supply ventilation, so if you're looking to introduce that outdoor air, we have anything from a simple motorized damper up to dedicated supply fans. And then finally, balanced ventilation, which will be a main focus of our conversation today, with a full offering of HRVs and ERVs. And again, we'll cover what those options are as it relates to the Pennsylvania code change. So with that, I'll turn it over to Pat.
All right, thanks, Travis. So first, we're going to focus on single family and low-rise multifamily. For those of you that work in that space, essentially it's single family, two family, townhome. And when we say low-rise multifamily, that's up to 3 stories. That's the way the code breaks it out, up to 3 stories. And then later on, we'll talk about the 4+ story, what we call high-rise. So for this initial single family and low-rise multifamily, there's really no change. State of Pennsylvania has been on the 2018 model codes for a number of years now. And when it comes to these types of dwellings, when they switch to 2021, nothing's really changing. So good news there if you have nothing to worry about there. So just kind of a FYI, if you're familiar with 2021 Energy Code, the IECC, maybe working in other states, one of the requirements in there is that you pick an additional energy efficiency option. Just to let you know, as a FYI, Pennsylvania has deleted those, so you don't have to worry about them. If you were thinking those are going to happen in Pennsylvania, they're not. They added some very specific insulation options, which we won't deal with today. Secondly, energy rating index. This is kind of a significant change that Pennsylvania has made. Back in 2015, they made these modifications as far as the maximum levels, and they've carried those over as they've gone to 2018 and 2021 I codes. So if you look at the climate zone maps at the bottom, this is noteworthy. The current code that Pennsylvania is under for the rest of the year here, you'll see has a little bit of climate zone 4 down in the very southeastern part, Philly area, some climate zone 5, and in some northern areas, climate zone 6. When the 2021 I code comes out, IECC, they adjusted their climate zones north. So you can see Pennsylvania no longer has any climate zone 6. It's all 4 and 5. So if you choose this energy rating index compliance path, if you're in climate zone 4, you just need to stay 62 or below to meet the code. If you're up in climate zone 5, you need to stay 61 or below. As you know, ERI is essentially like your HERS rating. Lower scores are better. So, and I have noted there, these special levels that Pennsylvania has set up are different than the standard code. For instance, in climate zone 4, the IECC says you need to be 54 or less. So essentially Pennsylvania, if you choose this compliance path, has made it easier to hit these code levels. So now I'll shift gears and go to that 4+ story multifamily, what we sometimes call high-rise multifamily. Again, so this is effective January 1. We're only a couple of weeks away now. The big change is all of these 4+ story multifamily will require the dwelling unit ventilation. Again, if you're not familiar with that term or the acronym DUV, it's the whole dwelling continuous ventilation. And probably more, maybe even more importantly, if you choose the prescriptive compliance path, which we understand a lot of multifamily engineers do, HRERV is going to be required. And Travis will be getting into that more later. If you look at that asterisk in the bottom, this is kind of a unique thing that Pennsylvania did. Normally when a state puts a code into place, it's kind of a hard permit date. If you pull your permit before there, you're on the old code. Pennsylvania is saying, if you have a designer construction contract signed before January 1st, you have an additional 6 months to actually pull that permit. So something you might want to think about if you're kind of on the cusp of determining which code you want to be under. So in the 2021 energy code, when it comes to the commercial side, which is the one that comes into play for high-rise multifamily, they give you some options. So you can either choose what they call section 40121 or 40122. And when you look at those within 40121, you have two options. Prescriptive path, if you're not familiar with code language, that's essentially a laundry list of checkboxes. You really don't have a lot of flexibility. You have to do all these things. You have the total building performance path, which is energy simulation software. And then third is this ASHRAE 90.1. ASHRAE is the same organization. You may have heard it. They put out the 62.2 standard. They also put out 90.1, which is an energy efficiency standard for commercial applications. Now, when you look within there, you can see in that first box at the top, you choose either 741 or 742 as applicable. We are going to worry about 741. I have highlighted in yellow there the word non-transient, which is apartments. Transient would be hotels and things like that. So we won't worry about that. We're focused on non-transient. So the key here, when you go H and ERV path, is, as you see underlined in red there, you need to be not less than 60% at heating design conditions. So if you look below, it's all based on climate zone, right? Since Pennsylvania is only climate zone 4 and 5, we don't need to worry about cooling design conditions. We're focused on heating only. So that kind of simplifies things a little bit. You only have to worry about one of the two requirements you have to hit. That last option we showed is a compliance path, ASHRAE 90.1. This slide kind of breaks that down. So if you look at the box to the left there, you see sections 5 through 10. These are the prescriptive path things that you have to hit. And I kind of highlighted in yellow there, item 6, heating, ventilating, and air conditioning. That's obviously the section where your ventilation is going to come into play. So we'll jump to the next slide. So here you'll see section 6.5.6, which it's in the section from that table of contents we just talked about. You'll see this language looks very familiar to what we showed in the prescriptive path for the IECC. It's the pretty much exact same language. Need to hit at least 60% heating design condition for Pennsylvania. There are some exceptions if, you know, a unit is under 500 feet, things like that. But for the most part, that's going to come into play everywhere.
Yeah, and the thing to point out here, that value, that at least 60% at that heating design, that's for what is a enthalpy recovery ratio. That enthalpy recovery ratio is a calculated value based on the performance of, in this case, an energy recovery ventilator or ERV. We as Broan have a performance calculator tool, online tool, easily accessible via our website. You can use the link here, otherwise also that QR code now showing on that screen. This is a very intuitive online tool that you can utilize and input your conditions. Need nothing more than your email address to get access to that tool. And again, it can be easily accessed via our website. Within that tool, just a high-level run-through, what you're able to do is input your project information as it relates to that location. So like Pat mentioned before, with the state of Pennsylvania, including both Climate Zone 4 and Climate Zone 5, our tool allows you to input that project location. So you can select your state, the nearest weather station. If you need help finding what that nearest weather station is related to your project location, basically where the building's physically going to be, we do have some different little help info boxes that will take you to like that ASHRAE site, in which you can input your actual address and ultimately tells you what your nearest weather station is to use inside this tool. Once you have input that, basically the climate zone as well as the elevation are all automatically fulfilled. So in this example here, I'm using the Philadelphia International Airport in this example. So I can input this data. You do see on the upper left screen there that ASHRAE 90.1 compliance. Again, you can select if that's yes or no applicable to your project. In the case of state of Pennsylvania, again, because of what Pat covered earlier, if you're choosing that ASHRAE 90.1 path, that is something you are going to want to make sure you're clicking inside this performance calculator tool. Within the tool, once you step through your design conditions, you will then have the ability to select what type of ERV you're using. You can do this either based on the characterizations that are shown here. So what style of ERV you want, the port location, is it hardwired, is it power cord, and ultimately it'll filter down to the available Broan SKUs, as well as you can also choose if you simply just know your airflow that's required. You can just simply hit your airflow and again, work your way through ultimately to what this tool is going to provide is once you've got your design data in, you've got your airflow in, you've selected your model, what it's going to do is provide a report out. Within that report, it's going to have all your project information, as well as basically a checkbox, a green checkbox as shown in the upper right there, that you are in fact compliant to that 90.1. And again, as Pat mentioned earlier, that's going to be based on your enthalpy recovery ratio. Again, because of the climate zone in which we're utilizing here, we've got to be at or above that 60%. In this particular example here, you can see we're at 77% and above, so easy to check that box. And again, we're only concerned with that heating design condition, or basically that winter condition there. So this is a fantastic tool. This is something that as you make your submittals, as whoever that code official, whoever's doing that verification that the project is in fact compliant to that latest energy code, this is something they're likely going to be looking for. And again, this tool is going to provide you a download link as well as a PDF copy of this full report, showing that based on the design conditions, based on the equipment you've chosen, that you are in fact ASHRAE 90.1 compliant with that enthalpy recovery ratio. So again, regardless of what path you were taking, whether you're taking that prescriptive path within that 2021 code, or you're going down that ASHRAE 90.1 compliance path, you are going to need this enthalpy recovery ratio number. And again, you can utilize this performance calculator tool provided by Broan in order to get that, basically get that checkbox or compliance, making sure your designs and equipment you've selected are compliant. I will say too, particularly in Climate Zone 5, just due to the colder weather, if you're going down that total performance path or that energy modeling side, you will likely find with the need for dwelling unit ventilation, you will likely find in running those performance models and running that energy modeling simulation that the use of an ERV is likely going to get you there as well. So again, if we're having to introduce outdoor air with an ERV because you are recovering the energy being removed from the dwelling, you'll likely find in your performance or energy modeling, it's going to be advantageous to use an ERV or use that energy that's being removed from the building in order to provide that outdoor air that's tempered and filtered. So again, depending on what path you're choosing, if you're going down that prescriptive path, you're going to need this enthalpy recovery ratio number, as well as if you're going down that ASHRAE 90.1 path, same thing, you're going to need that number. And like I said, typically what we're seeing is in those colder climate zones, typically an ERV is also favorable when you're trying to get to that total performance path. So with that, we're going to switch gears a little bit. So we talked about that enthalpy recovery ratio. For those that aren't familiar, we did want to run through the how to size, or basically that continuous ventilation rate that Pat had mentioned earlier. So we'll use a 1,200 square foot dwelling here, apartment, 2-bedroom apartment here. The ventilation rate is going to be dependent on basically 3 key things. The first is the square footage of that dwelling. So again, in this example, we've got a 1,200 square foot apartment. The number of bedrooms. So what that number of bedrooms is going to dictate is the occupants within that dwelling. So we're going to take that number of bedrooms, and then there's an assumption within the ASHRAE calculation that there are 2 occupants in a master bedroom. And then finally, ASHRAE has determined for our overall indoor air quality, 7.5 CFM of continuous ventilation is required per the occupant. And there's 2 ways this number can be determined. We can use the simple table that ASHRAE provides in that 62.2 standard. So again, we've got less than a 1,500 square foot conditioned area here, as well as we've got those 2 bedrooms. You can see here the continuous ventilation rate, if we use this table, is going to be 45 CFM. So again, that's the 45 CFM of continuous ventilation is what's going to be required for this dwelling. We also have the option, and you'll see this laid out within the code language. You'll see a formula here, and we're going to utilize, again, that 1% of that square footage. We're going to take those number of occupants. So again, this is a 2-bedroom in this example, plus additional occupant in that master. So we're going to take basically 3 occupants multiplied by that 7.5 CFM. And once we add those 2 numbers together, we're going to get 35 CFM of required ventilation, continuous ventilation. So you can kind of see here how those 2 numbers compare. Again, if you use that table, what you're typically going to find is that value is going to be higher. Or if you do the actual calculation, you'll see that number is typically a little bit lower. The reason I point this out is if and when you're using the energy modeling side, and you will find that even this small difference in ventilation rate, depending on your outdoor air conditions, may actually be more advantageous to use that lower ventilation rate. Again, if you're thinking about if it's a very cold day out as an example, even that 10 CFM difference between this calculated value and just using that table value may actually add up as you get more units inside that building. You may find that using this calculated value is actually going to be advantageous to use inside that energy modeling because you'll get less of a penalty, I'll say, due to the ventilation rate for these dwellings. So again, this is how you're going to size your ventilation for this latest code. And again, we talked about previously that enthalpy recovery ratio and how this all intertwines when determining what piece of equipment you need for that given dwelling. So with all that said, we'll jump over to products now. So we've covered the code, we've covered how we're sizing the equipment, how we're getting that enthalpy recovery ratio value. Now let's talk about products themselves. And so knowing we're focused on that 4+ story multifamily dwelling type setting, we're going to be focusing on a Broan-1 series of ERVs. This is a product line that was introduced back in 2024, has been very successful, particularly in these multifamily dwellings. So other states have already made this transition over to this latest round of code in those 4+ story dwellings. This is a very, very popular platform, and we'll kind of run through the why. It also give you some real world examples, applications that we've seen in other areas of the country where these products are physically being installed and some of the considerations related to the use of these types of piece of equipment. So When we developed this ERV platform, we were very cognizant of the overall profile or form factor. So again, knowing in the multifamily side, those high-rise type dwellings, floor space is a premium. And so more times than not, we're always trying to look for different areas of the dwelling, whether it's a ceiling cavity, a soffitted ceiling, or just honestly, just trying to take up as least room as possible, just because square footage is such a premium in these types of multifamily dwellings. So we were very cognizant of that. That ultimately led to a low profile design, or being less than 10 inches in overall height. We understood that, again, if you're putting this into like a soffitted ceiling assembly, again, we're trying to maximize the ceiling heights inside these multifamily dwellings, these apartments, these condos. So again, making sure we take up as less room as possible inside those soffitted ceilings. Recovery efficiency. So you saw earlier how that recovery efficiency matters when we do these energy modeling exercises, or just looking to maximize the recovery efficiency. So SRE, or sensible recovery efficiency, is basically the transfer of temperature. Basically the benchmark in the industry, for the most part, is about 75%. You're going to start seeing these numbers creep up higher and higher, meaning 80+% is becoming more of that higher end. And you can see here, this Broan-NuTone series is at 84%. So we've really raised the bar when it comes to that overall recovery efficiency within these products. As you saw with that ventilation calculation and that CFM, with the development of this platform, you want to be very cognizant of making sure you have the ability to specify one SKU or one platform throughout that entire development. So you have the ability for this product to dial the CFM in one CFM increments from 35 all the way up to that 155 CFM. So if you've got that very small studio apartment, or you go all the way up to maybe that penthouse on the upper level where you've got multiple buildings, larger footprint, you have the ability to cover all of those needs within this platform and not have to worry about multiple different SKUs. It allows that installing contractor to always be installing that one SKU and simply dialing that CFM in to whatever that necessary need is for that given dwelling or floor plan. Filtration, so we are introducing outdoor air. This unit does come with MERV 8 standard filtration that's washable. If we're more cognizant or need additional filtration levels, we do have an optional MERV 13 disposable filter that is 2 inches in thickness. Again, if we want that additional level of filtration, we do have that capability inside this platform. Virtual is a technology we introduced back in late 2020 with the introduction of different platform. We'll kind of run through what virtual means as it relates to the overall performance of the product. And finally, we have a full suite of wall controls. So depending on the capability that you want to be able to control this unit, we do have the ability, and we have offerings in different wall controls, from the most basic to, as you can see on the left there, that touchscreen control, which has a full suite of different features in which you can make the ERV operate in. Something that's unique to this platform in the industry, as well as what it really helps, is in those multifamily designs where we've taken a floor plan and we've simply mirrored it, whether we've mirrored it across a shared wall assembly or we've mirrored it across like the corridor. What we've introduced with this platform is what we call in-field selectable airflow configuration, or essentially what we're able to do is, if we've got a design like you show there in the upper right corner, where we've in the floor plan on the left, everything's great, ductwork looks nice and clean, we found a good spot for this ERV to be placed. We then try to take that same location and translate it into that floor plan on the upper right there. As you can see, that ductwork gets more complicated, leaves opportunity for, I'll say, creative freedom out in the field. If the ductwork isn't clean, they might take the opportunity to route it differently than you've got planned. With this in-field selectable airflow configuration and this integrated switch here shown, is you can put that ERV in the same exact spot. You can route that ductwork cleanly, like you can see on the lower right example there. And we have the ability in the field to dictate on which side of the ERV the exterior ductwork is running to and from. So that really cleans up the ductwork, as you can see here, as well as it provides opportunity to specify that same SKU in floor plan A and floor plan B. From a overall distribution standpoint, installing contractor standpoint, we're also simplifying those lives. They're not worrying about having to have SKU number with the standard airflow and another SKU number for that mirrored airflow. So again, we're simplifying that location. We found a good spot for this ERV to be placed. We're able to make that ductwork as clean as it can be, given that location. Again, that model specification, we're not worried about, do we have the right mix of SKU numbers between floor plans? And finally, that install configuration. So if you're an installing contractor and you've got a couple hundred unit job, it's really rinse and repeat. You're not having to be concerned with, did I put the right ERV into that dwelling to be physically installed? It's always that same ERV, putting it up there, just dictating which way that airflow is going by using that switch. I don't like to advertise this, but I will just make a statement as well. Our product does have the intelligence to actually know over a short period of time what the outdoor air, that exterior air actually is, and we'll make the necessary programming changes inside of it without any external intervention to actually basically know what that outdoor air is being introduced through and make that necessary change. So I'm not advertising the fact to not interact properly with this switch and actually set it properly. Just do know, have a peace of mind that our system is intelligent enough to actually recognize what that outdoor air is and make the necessary internal adjustments accordingly because of that. So virtual, I mentioned it before. Virtual is a fancy term we came up with from a marketing side. There's really three key things. And the first is auto balancing. So for those that are familiar with ERVs or this type of balance ventilation technology, balancing is critical to the overall performance of the product, as well as making sure that the pressure inside that dwelling is neutral or, again, balanced. This virtual technology does that balancing step for you automatically right up at startup, instead of having to use manometers, having to adjust balancing dampers. Anything that you would have to manually intervene to do that balancing is all done at the beginning of this. And the product stays balanced throughout its operational life. So it's detecting conditions, changing conditions, whether it's outside or inside, and adapts in real time. So if we set the value for that CFM, the unit is going to continue to make adjustments to its operation to always get back to that set CFM it was at that initial commissioning. So once balanced, always balanced. We're going to make sure that the engineering, the specifiers said that the unit needs X CFM. The installing contractor uses the integrated LCD screen to set that CFM, and then basically the unit takes over, or virtual takes over, and make sure that we're always hitting that targeted CFM that it was set to at the very beginning. And finally, artificial intelligence. So again, back in 2020, when this was introduced, long story short, basically our engineers have, lack of a better term, taught the machine through thousands of different scenarios. If X happens, there's a number of internal, basically, mechanisms that the unit has to always get back to that set CFM. Artificial intelligence piece. So again, we've taught it multiple different ways. There's things that we haven't thought through, situations it hasn't run into yet. Long story short, the unit learns from those types of events, kind of logs that, knows the next time around those types of variables happen. It'll make that adjustment more quickly than having to kind of go through a number of checks and balances before it gets back to that set CFM. So again, optimizing that indoor air quality 24/7, 365 around the entire time. Versatile installation. So we talked about it before. Again, depending on where it is you're looking to physically install this type of product, this 1 series has the ability to mount in a number of different orientations. Could be put on that vertical orientation, or like on a wall as an example. That ductwork is going to run horizontally. Or also can mount it with the door up or that door down. I'll show some real world examples on where this can be advantageous to do. Again, just be mindful that this unit does have the ability to mount in various orientations. Because it is an ERV and because of how we go about designing this, it does not require any kind of condensate drain of any sort. So that really allows a lot of freedom on where this can physically get installed, not having to worry about running that condensate drain to a certain location. Again, you have the ability to mount it in these types of different orientations without any concern about that. We've talked about the Broan-1. We're going to transition now into our newer interior ready model. So as you can see from the picture there, the unit comes with a pre-painted white door assembly and trim kit. So to give you an idea of what this could look like, this is an example here sitting in a laundry room. Again, you have the ability to mount this into a ceiling or wall cavity, which again will free up that floor space. We have made sure, I will show a little bit of detail here, how we've designed the mounting brackets as well as that trim kit, how we can get a consistent install quality, so the look of the unit once it's installed. Again, a little cutaway there. You can see how we're going to sit inside that ceiling cavity in this case, and still have full in-room access to anything we could possibly need from a maintenance standpoint, from a service standpoint. Again, driving visibility that this thing exists. One other thing with this interior ready design, not necessarily pertinent at this moment for Pennsylvania, but there is a requirement that's been implemented in a few states, which is the fault indicator display. Essentially, if there's a fault with the system, making sure that the unit identifies there's a fault, and then there's a visual indicator requirement for that dwelling occupant that the system has had basically a fault. And there's a whole suite of faults that need to be triggered. Just basically, long story short, know that with this interior ready design, that is already incorporated onto the product. There's an integrated indicator maintenance light that will shine through, and basically you'll see this little amber light illuminate and notify that dwelling occupant that there's a fault with the system. A little detail here, I mentioned before how those mounting brackets physically attach to the ERV. You can dictate on the overall thickness of that ceiling or that wall assembly, and then that helps set the height properly for that trim kit as well. So again, this is going to be as level as whatever the mounting structure it's mounted to. But again, you have the ability to set that height so that we get a nice clean finish between that ceiling or that wall assembly and that trim kit, so we can provide a nice quality finish at the end once it's all installed. Just a couple real world examples at roughing here. You can see this one's installed between a floor truss system. We've got that ductwork running to and from. So that's on a basically a 24 on center open web floor truss system. If you were to go to like a ceiling joist system where you got that 2x6, 2x8, whatever it might be, in a vertical orientation, this unit does accommodate that as well. You can see here in this example, these are hardwired models. And so we put that electrical basically connection on the side in which we've added some 2x too, just to give us enough area, enough room to make those electrical connections from inside that door assembly. Different example here, again, depending on where it is you're designing, it's not uncommon for bathroom ceiling spaces to be the sacrificial lamb and put as much as you can in those ceiling assemblies. Again, this is just an example, very pretty looking bathroom where you have this interior ready model physically in that bathroom to get access to those areas. Again, different areas you can look at: closets, hallways, mud rooms, mechanical rooms. Again, a full suite of different areas in which you can put this ERV physically in. Maybe asking, we showed that galvanized door model. We've got this interior ready model. You know, what's a good spot to use this galvanized door model compared to that interior ready model we just talked about for the last few minutes? Again, if you've got a mechanical room where it doesn't really matter, you know, looks aren't everything, you've got other mechanical equipment in there, great application for this galvanized door model. Or if you're having to put the ERV into like a soffitted ceiling assembly, maybe it's for fire rated applications or just in general. Or if you've got a 24-inch deep closet, this unit is sized appropriately to fit inside that closet, like shown there in the lower right corner. Again, if you have an access door that's required there, again, you can set that unit inside there, again, minimizing the impact that the in-suite ERV that we're showing here has in the overall design, as well as the overall finished space of this dwelling. One last thing I want to point out on the product side, again, we're going to have to move air to and from the outside for an ERV. We do offer a few basically concentric or TEM terminations. We've got two models. What this does is it allows for the outdoor air to be introduced, as well as the stale air, the exhaust air from the ERV to go through one penetration through that wall assembly to the outside. And so depending on what your needs are, we've got our VTYK1 that is going to go through a 6-inch hole, diameter hole. And again, you can see there how the exhaust air is going to exit out the top side of that termination. And then we're going to draw the outdoor air in through the bottom side. And again, we're separating those airflows and ultimately feeding that air and taking that air to and from that ERV. We also have a V14695, which is a side-by-side or metal termination. We're going to basically dissipate those airs in a horizontal orientation. You can see here in the next examples of some real-world applications here. We've got that 14695 or that metal termination on the left. You can see how it can kind of correspond to varying claddings, whether it's a brick on the bottom or a more flat-faced fascia on the upper units there, as well as our VTYK1, which has more of like a traditional type exterior look, where again, you can see how that's protruding outward. And again, we've got that outside air going out the top and that outdoor air incoming from the bottom. So again, some real world examples here of showing how these terminations can correlate to the use of an ERV. Very, very helpful, particularly in those multi-family dwellings where, again, you can see in these examples where, those units are very close to one another. We do get questions, particularly from code officials or, AHJs asking, how can you have the outdoor air being introduced right from the stale air that's leaving the building? We do have internal testing we've done. We can provide that documentation. So if you ever get asked or a question comes up, feel free to reach out to us. We've got that internal documentation showing that contamination rate between these, that outdoor air being introduced and that stale air leaving the building is less than 5% with either of these two terminations. So again, if you're in a bind or, as you start to implement these in-suite ERVs into your designs, and it's advantageous to have it go through that one termination. And if you get any of those questions, feel free to reach out. More than happy to provide, whether it's yourself or whoever that code official that may be providing that ask, more than happy to provide you that additional information to satisfy those needs. So with that, I know we covered a lot. I know Pat covered a lot with the code side of things on the ventilation side. I know I've been babbling for the last 20 minutes or so on the actual product side. I don't see anything currently in the Q&A or chat, but anything, Michelle, that you're seeing?
No, nothing yet. We'll give it a couple of minutes. Feel free
Okay.
to go Q&A or chat if there are any questions. Be happy to answer those. Or if any come up afterwards, you can certainly email Travis. We'll make sure we provide your email in the follow-up if that's okay.
Yep. Yeah, and as
Okay.
Michelle stated at the very beginning, again, you guys will, any of the participants that are on the call today or any of those that signed up, will be getting a copy of this webinar or some other information collaterals following this. So again, we're here to support you as relates to navigating these codes. And again, the changing environment, as Pat walked through earlier. Does look like we just had one come in related to kitchen ventilation. Let's see what it said exactly. So from Chris, is there any changes regarding kitchen appliance venting? That's
No, not really.
Okay.
Not in the model codes, as we call them. California's had some recent changes, but in other states, it's not as much going on in kitchen as
got it.
far as codes and so on.
Michael had a question. I'll actually go back to that picture. So in that VTYK1 that I'm showing now on the right side, there's an additional termination there. Yeah, Michael, that was actually for makeup air. So that was an outdoor air source. This particular project was in Washington State. We did have to work through with that code official, having that makeup air relative to the location of the basically that exhaust that's coming from the ERV. So again, that's where we can provide that additional help. We were able to provide them some internal testing that we had done on the velocity in which that exhaust air was leaving the ERV and just basically showing how that had minimal impact on that makeup air that was getting drawn through that termination that's next to it for that dwelling. Hopefully that answers your question, Michael.
Give it a couple more minute or so for more questions.
So Chris had a question. Is there any condensation created by the ERV that we need to be managed? So, Chris, short answer is no. So how we designed the unit, both with the overall design of the, basically there's an insulated shell inside the ERV. So we're minimizing the temperature transfer that would happen like within the housing. So no, we do not have to be concerned with condensation and you guys having to manage it in any way. That's all done within the ERV itself. Even in the most extreme climates, one way or the other, we test all that, make sure that we're not having any significant condensation collection. And again, that's going to be managed within the ERV itself. So nothing you actively have to do really to running a drain or anything unique. So put that ERV where you need it and don't worry about any kind of condensation requirements externally for that. Michael had a question. Are there any issues with locating the ERV or access panel directly above the shower regarding humidity and moisture? Again, not anything related to the ERV itself or the access panel, Michael. The ERV door has a seal that goes between it and basically the internal components. So we're gonna minimize the amount or the chance for any kind of additional interior air to enter into the ERV, which would possibly cause some moisture concerns there. So nothing related to the ERV operation or access panel. I would say just be mindful of local code, depending on that code official, as relates to how, if the electricals run to the ERV, just making sure that, again, any NEC or any National Electric Code requirements are taken into account there. Best practice, again, if you're going to put that in there, that the ERV is sealed, typically with like a caulk between that ceiling penetration, that drywall or whatever you're using on that ceiling to the ERV. Again, just minimize the amount of air leakage that we could have when that drywall cutout's made around the ERV. Is just best practice. So again, nothing from an ERV standpoint, Michael. It's just again, best practice from an air leakage. Good questions. Glad we're getting this out ahead of us. Like I said, we're here to support you. As I mentioned earlier on in the call, this transition has occurred in multiple different states. And so we've had these same types of webinars for multiple states. Washington State comes to mind. They made a significant change over the last few years where most, if not all, multifamily dwellings in the state of Washington going up that are that 4+ story physically has one of these types of in-suite ERVs inside of it. So a lot of learnings that we've experienced over this time as people transition. For those that aren't familiar with ERVs or this type of technology, it's been something that's been used widely throughout the entire country of Canada for quite some time. For if you got any friends just over the border in Toronto or Montreal, where a lot of high rise is prominent, again, you're going to find this same type of install, this same type of unit. So if you got any colleagues over there, any other contacts, again, feel free to pick their brain. Like I said, this is something they've been doing for a very, very long time. And again, it's something Broan, we've been in that market as well for the last 40+ years now. So we have a lot of knowledge as relates to both that climate as well as, again, throughout the United States in helping with these types of application questions. So.
All right, I don't see any other questions coming in. We'll do a last call. And in the meantime, thank you so much for participating. We know it's a busy time of year. And again, as Travis has mentioned, you'll get the recording and we will include emails for you in case there are any other questions that come through. So I guess we can close. So with that, happy holidays, everyone, and enjoy the rest of your day.
Bye. Thank you
again.